All right, just a little bit more with quadratic functions. You also have questions that ask you to find the, oops, wait, I'm on the wrong thing. Let me get to my snip. Which one was it? I think it was this one. All right, so you also have these questions on that optional practice homework that ask you to basically find the vertex, think about whether it's a max or a min, that type of thing. So on this one, it never mentions the word vertex. It just says determine whether it has a max or a min. So you should know, though, that the vertex is the key. Okay, so this particular one has the equation in standard form. So to get the vertex, I'm going to do negative b over 2a. Okay, so the opposite of negative 20 over 2 times 2, and just work that out. So that's going to be positive 20 over 4, which turns out to equal 5. So the x-coordinate of the vertex is 5. Now, to get the y-coordinate of the vertex, I'm just going to find f of 5 by plugging into the formula. Okay, so you can show your work by showing this, and then you can let the calculator evaluate that for you. Especially if you're not really good with order of operations. Okay, so the squaring would happen first if you're doing it by hand, and you'd get 25. 20 times 5 would be 100, still negative. So this would be 50 minus 100 minus 1. So that turns out to be negative 51 when I'm finished. All right, so I know my vertex is this. All right, now let's think about this parabola. Okay, to determine whether it has a max or a min, I need to really think about how a equals 2. So I know this parabola is going to be opening up because a equals 2. And then this vertex is going to be at 5, negative 51. Okay, but we know it opens up. Okay, so that means that, notice when you look at the picture, if it opens up, that means that that's going to be a low point. The vertex is a low point, which means it has a minimum value. All right, now the part B comes from the vertex. The min or the max value is the y-coordinate. So is negative 51, and it occurs where x equals 5. Okay. Now it asks for the domain of the function. The domain, it is a function. It is a parabola that opens up that keeps going out in both directions. So the domain would be negative to positive infinity. And then the range, you really need to look at the picture to get that correct. So when you're looking at the picture of that, you notice how the lowest point would be negative 51. Okay, the lowest y would be negative 51. Put a bracket on that, and it would keep going towards positive infinity. By the way, on part A, you'll have the choice of just circling whether it's max or min. So you would have had that come up, and you would have bubbled in that it's a minimum. Okay, so let's go ahead and do a couple of application problems related to that. So let's look at question number 20. So here we have a ball is thrown upward and outward from a height of 7 feet. The height of the ball can be modeled by this equation. X is the horizontal distance from where it was thrown, and we're supposed to answer all of these questions. Okay. All right, so when we're looking at this, first thing you should be thinking is it has a negative a value, so you know it's opening down like all the pictures are showing. Okay, so you're thinking that it's a parabola opening down. Okay, and that 7 right there is where it's crossing the y-axis. Okay, so that spot right there. Okay, and then it goes up and comes back down and hits the ground. All right, so first question we're asked is, what is the maximum height of the ball and how far from where it was thrown does this occur? Okay. So they want us to find this spot right here. And notice it says round to the nearest tenth as needed. So we're going to be typing in, let me grab a calculator real quick. We're going to just be typing in to get our answers there. So I'll be working on using the vertex formula to find the x-coordinate of the vertex. So to get the vertex for this point right here, I'm going to have to do the negative b over 2a. So I'm going to do negative 1.2 over 2 times negative 0.1. Negative, opposite of the b value, over 2 times the a value. Okay, so that would be, let's see what that would be, divided by, and watch these horizontal fraction bars. You would need to be sure you enter that correctly. So you might want to put an extra parenthesis or just work out that denominator first. So the x-coordinate of the vertex turns out to equal 6. So we know this is 6 something, and then we need to find the y-coordinate of it. So to get the y-coordinate of the vertex, I'm just going to plug in 6 to the formula. So I'm going to just type in this, plug in the 6, and work that out. Okay? So let me do that. You do the same. Take the negative 0.1 times the 6 and square it. Just use your calculator because you know you're supposed to just round when you're finished. 7. Okay. So I wound up with, let me turn a light on here, wound up with 10.6 for the y-coordinate rounded. Actually, it turned out to be that exactly 10.6. Okay. I'm going to double check that I entered it right by looking back at what I entered. Make sure I put in a 0.1 times the 6 squared, 1.2 times 6 plus 7, and I got the 10.6. So the maximum height would be the y-coordinate, would be 10.6 feet, which occurs, see, so that would be 10.6. The x-coordinate would be how far horizontally from where it was released. So that would be the 6 feet. Okay. Now, this next question requires more work than you might expect. How far does the ball travel horizontally before hitting the ground? They want this right here. That's going to be one where you're going to need to use the quadratic formula. An x-intercept. This is actually going to be the quadratic formula. So I'm going to plug into the quadratic formula and do the opposite of b, plus or minus the square root of the b squared, minus 4 times the a value times the c value. And then all of that's going to get divided by 2 times the a value. Okay? So be careful working that out. So here we're going to wind up having negative 1.2. Down in the denominator, we wind up having negative 0.2. Okay, then we have plus or minus, and then under the radical, I'm going to work all of that out. Let me get rid of that 7 for a moment so it's not in the way. I'm going to work that out. I'm going to do 1.2 and square it, minus 4 times negative 0.1 times positive 7, and just hit enter. And that gives me 4.24 under the radical. Now it does say I can round, so I'm going to do the square root of that answer, okay, which is 2 point, and then it's like 0.059 and all of that. I'm going to keep that longer and round after I've taken care of this right here, okay. So that part right there, this part right here, was 2.059126028. It says round to the nearest tenth as needed. You really shouldn't round until you get to the end, so I'm going to keep that in there. And then I'm going to add the negative 1.2 to it. Then I'm going to divide it by the negative 0.2, and that gives me one answer. Okay, so when I did the negative 1.2 plus the square root of 4.24 over negative 0.2, I wound up with about a negative 4.3. Then I'm going to do the negative 1.2 minus the square root of the 4.24. Okay, hit that answer and divide by the negative 0.2, and I get, so when I do this one, minus the square root of 4.24 all over negative 0.2, that one gives me about 16.3. Okay, so where that negative 4.3 comes from is if that quadratic function was drawn, it would have hit here, and the quadratic function would have had two x-intercepts, but that one wouldn't have made sense. So the answer should be the 16.3 feet. Okay, 16.3 over there. Okay, so really it works best just to type these in right here. Just make sure, and let me try that first one, make sure I type that correct, because it's easy to not hit enter. So let me try that one again, make sure I hit enter like I was supposed to. So I'm just checking that top one to make sure that I don't mislead you by typing it in one more time, making sure I hit enter after I typed in the numerator. Yeah, I did, and got that negative 4.3. Okay, so type those in, and then the negative one wouldn't make sense in this context, so you'd rule that out, and then you would put a 16.3 in. All right, so now when you're trying to get the graph of it, really, when you're looking at that, the y-intercept is 7, so that actually can rule out this one, and this one. And so it has to be C because it has to have a y-intercept of 7. But then notice that the rest of it fits. So here's your vertex, 6, a little bit to the right of 5, and then a little bit above 10, so that makes sense. And then the x-intercept is around 16 something. Okay? All right, let's do one more in context. All right, and here's a similar situation, but this object is being projected upward from ground level. And so it's also going to be opening down, right? But it's starting right here at the origin and then going, oops, let me draw that better. Starting right there at the origin and then going up and coming back down at some point. And this one says, find the number of seconds it will take to reach its maximum height, and then what is the maximum height? You're the one who needs to know. If it wants to know the max or the min of something, that's the vertex. So I'm just going to look at that, and the b value is positive 80, so the opposite of 80 over 2 times negative 16 would be the x-coordinate of my vertex. So I need 80 divided by 32, which is like 2.5. Okay, and it's exactly 2.5 for the x-coordinate. Then I'm just going to come back in and get S of 2.5 by plugging in the 2.5 everywhere there was a t. Let me see if it'll let me write over there. Good. All right, so I'm going to take negative 16, put in the 2.5, close the parentheses, square that, plus 80 times 2.5. All right, this is showing me your work. If you're rusty on order of operations, just type that in and hit enter, and I wind up getting 100 when I do that. Okay, so then you got to make sure you answer the question correctly. Okay, so you have to think a little bit about the setup here. So the t is like the x, and the s is like the y. So this is the number of seconds, the time in seconds is here, and then this is the height in feet. Okay. So on this one, you wind up getting the vertex to be 2.5, 100. So that means the object will take 2.5 seconds to reach its maximum height, and the maximum height will be 100 feet. Initially, I was thinking about this like the previous problem when I said it starts on the ground, but actually this is not the path of the ball. This is not the path of the ball in this context. I didn't read it carefully initially. This is just the height at various instances of time. So it's not the actual path of the ball. It's just how high it was. So when initially it was on the ground is why I started it here. Okay. And then after 1 second, after 2 seconds, after 3 seconds, and so on. we're just recording the height. All right.